Hello! So today I'm going to talk to you about standard deviation. Lesson objectives then, we'll look at some of the different types of statistical tests and just have a very brief think about what those are used for, although this video is mostly about standard deviation. So we're going to learn how to use standard deviation, and I'm going to go through an example of this and then you can have a go at practicing it for yourself. So just having a quick think about different types of tests. There are lots of different types of tests, and the type of test that you choose is going to depend on the sort of data that you've got and what you're actually trying to prove with that data. So we'll pick different tests depending on what you're trying to prove. Standard deviation is what we're talking about today. So standard deviation is about the precision of the data, and we'll have a think about that a little bit more in just a moment. A t-test then is used to compare means, and we'll have a look at that in another video. And in another video following on from that then, we'll have a look at Spearman's rank correlation coefficient. That is used to confirm a relationship or a correlation between variables, but we'll talk about that in a different video. We've got chi-squared as well. So chi-squared is used to compare observed and expected results. So for that you need some kind of strong theory so you can try and figure out what the expected results are going to be. But today's lesson is all about standard deviation. So standard deviation, as I said, is to assess the precision of the data. So from the specification then, this is what they describe accuracy as, because people often get accuracy and precision mixed up. So accuracy is a measure of the closeness of agreement between an individual result and the true value. And if your test result is accurate, then it will be in close agreement with the true value. But often actually we don't actually know what that true value is, so it's not known. And precision then is the closeness of agreement between individual measurements under the same conditions. So it depends only on the distribution of random errors. So the spread of measurements does not relate to the true value. In short, accuracy is how close the test result is to the true value. And precision is how close the individual measurements are to each other. So if we look at this target just here, we can see, because this dot in the middle here of our target represents the true value. So this one here, you can see, has got high accuracy and high precision. You've got all of your individual measurements close together, and they are close to that true value. Here we've got low accuracy because they're not close to that true value, but we have got high precision, so they are close to each other. So they are precise. And this one here, you can see that they are close to that true value just here. So we've got high accuracy, but they are not close to each other. So we've got low precision in this case. And this one here, you've got low accuracy because it's not close to that true value, and they're not close to each other. So you've got low precision there as well. So standard deviation, yes, it's a measure of the precision of the data, but we would say that it's a quantitative measure of the spread of data around the mean. And here we've got our equation for that we use. So it's a quantitative measure of the spread of data about the mean. And most of that data is going to fall, or a large proportion of that data is going to fall within one standard deviation from the mean. So 68% of the measurements will be here. 95% of them will be 2 standard deviations from the mean, within 2 standard deviations from the mean, and then 99.7%, majority of the rest of them then will be within 3 standard deviations from the mean. So 68% of the data then lie within 1 standard deviation either side of that mean, and 95% within 2 standard deviations either side of that mean. The symbol then for standard deviation is the Greek letter sigma, this one here. And some people would describe it as the square root of that variance from the mean. So just thinking about what each of these symbols mean to make sense of the equation. This symbol here, that is the sum of, so it's when we add things together. X in this instance represents the individual measurement, and X bar, that's this one here, the X with a little bar on the top, we call that X bar, is the mean, and N is the number of measurements or data points. So standard deviation, when we get our results, then we can actually look at the spread of that data from the mean. And here we've got quite a small standard deviation, so that means that all of those data points are pretty close to that mean value. So we've got a narrow range, and we can tell then that our results are precise. Here you can see that the data is really spread out from the mean. So we've got a large standard deviation here. You've got a very large range, and those individual measurements are pretty far away from the mean value here. So these are a lot less precise. We'd say this has got low precision here. So we need to do these things, these steps in the right order, and that's really important actually, because you do get given a lot of these equations, but you need to know how to use those equations. So we would start off with calculating our mean, and then you would subtract the mean from the individual values. You'd square those, square them, and then add those together. Divide them then by n minus 1, and then find the square root of that. So I've got step by step here. So you're going to calculate the mean, you're going to calculate the difference, so subtract the mean from each of those individual values. You're then going to square those differences, you're going to add those values together, divide them by n minus 1, and then find the square root of that. So starting off here with the calculation of the mean. So to calculate the mean, I'm just going to add up these individual measurements. And the example is height of dogs. So we've got lots of dogs and we've measured the height of those dogs. So for the mean, we're going to add them all together and then divide them by n, which in this case is the number of measurements. We've got 5 measurements there, so we're going to divide it by 5, and that gives you 394. And then we're going to calculate the difference. So to calculate the difference then, we're going to take the individual value here, the x, and then we're going to take away the x bar here. So 600 minus 394, which gives you 206, and then you can see I've done that for each of those. And then the next step then is to square that difference. So once you've worked out your difference, then you can square those differences. So here the difference was 206, so we can square 206, which gives you 42,436. And you can see that I've done that for each of those. So that's step 3. And then step 4, we're going to add all of those together. So if we have a look at this column just here, added up everything in this column to get this sum of just here. And then we're going to divide that by n minus 1. So n is the number of measurements that we've got here, which is just 5. So 5 minus 1 is 4. So divide it by 4, and then find the square root of that. So now we've got our standard deviation, it's 164.71. What does that mean? We can have a little think about that. So I've rounded it to 165, makes sense, to the nearest whole number. And that means that most of the values, 68% of those values then, are within or we would expect them to be within 165 millimetres from that mean height there. And then our mean is 394. And then you've got some outliers then that are further away from the mean. In terms of our data, we need to think about the standard deviation. It's relevant to the mean. Now, actually, this one is quite a large standard deviation because our mean is 394. So 165 is actually quite a big number compared to 394. So that data is pretty spread out from our mean, which, to be honest, is kind of what we would expect because those dogs are different breeds and they probably have different diets and different environmental factors that are going to affect their height. So you would expect those to be quite spread from the mean value. Okay, so I've set some work for you to do. You can have a go at that. We've got the step-by-step here, so you can always go and have another look at the video if you want to, or use the step-by-step to help you to work out the standard deviation. Okay, any questions, you can email me. Thank you. Bye.